Today we're going to be looking at square root functions. So far we have talked about square roots in lots of different ways. We've talked about simplifying them, we've talked about adding, subtracting, multiplying them, we've talked about rationalizing denominators that have square roots, we've talked about equations that have square roots, and now we're going to look at graphing square root functions. So before we get into actually looking at the graphs, I want us to just talk about the basic equation of a function that has a square root. It looks kind of similar to a quadratic. So in the center of your page, we are going to make a multi-flow map. So in the center, kind of in the middle, we want to put the function, and then we're going to have some causes and some effects of parameters on that function. So we'll start with just in the center, y equals, and this is our square root function. It looks like a times the square root of x minus h, and that's where the square root stops, plus k on the end. All right, so we are going to have some input values. So if a looks a certain way, or if a is a certain value, that is going to affect what happens to this parent function. Okay, so there are three possibilities for a, very similarly to when we were dealing with quadratics. It's very similar to that. So first of all, if a is a number that's larger than 1, that's going to give you a vertical stretch. If a is a number that's between 0 and 1, in other words, if it's a fraction or a decimal between 0 and 1, that's going to be a horizontal stretch. And finally, a can be a negative number. If a is negative, that is going to give you a reflection over the x-axis. In other words, it flips. All right, so that's what happens when you have an a value other than 1 in front of that square root. Okay, so now let's look at the h value. I want to remind you that there is this minus sign that's part of the function. It stays as a minus, so that kind of affects what happens with the h value, very similar to how it affected a quadratic with an h value. Right, so the h, here are some options. Right, if it says plus h, I'm going to say this. If it says plus h, that's going to be the opposite of what you would think. That's going to be a shift to the left. If it says minus h, that's going to be a shift to the right. And that's all there is for the h's. If h is 0, or if there isn't an h value, it doesn't move at all to the left or right. And finally, what happens when we have a k value? Right, so there are a few options for k. Right, k is either a positive number, so if you have a plus k, it does exactly what you would think. You shift up, similar to quadratics. If you have minus k, it's going to shift down. And that's all there is to k's. So I do want to show you what these look like in Desmos. So I'm going to pull up Desmos and we are going to look at some effects of these graphs, and we'll do a few examples down at the bottom of this page. Alright, so I've pulled up Desmos and we are going to do a couple of examples together. So for example 1, I'm going to give you the equation y equals 3 times the square root of x minus 2 plus 1. And we're going to describe how this has changed from the parent function. Okay, so the parent function, let's make a note of what the parent looks like. The parent graph just looks like y equals the square root of x. So if we add in all these numbers a, h, and k, that stretches it, moves it to the left or right, moves it up or down. So the original function y equals the square root of x, looks kind of like a sideways parabola, but only half of it. So notice how it kind of starts at the origin and goes up and curves a little bit. It's not a straight line, but it looks kind of like a sideways parabola that's also been cut in half. So when we add in these a, h, and k values, let's just look and see how the function moves, how it stretches, moves left or right, up and down from this original function. So I'm going to type in our second equation here, y equals 3 times the square root of x minus 2. And then notice I've got to move my cursor over so that I'm not underneath the radical anymore to do the plus 1. All right, so you can definitely see how this function has been stretched. I can even click the home button to go back to a regular zoom. So you can definitely see how this has been stretched. So that's one change that was made. And we'll say this is a vertical stretch by a factor of 3. So vertical stretch by 3. The h value, we want to know how that has affected it. So our h value, since it says minus 2, that means we're moving right 2. And the k value plus 1 tells us that we've moved up 1. Now, I want us to see how we can tell where we've moved from. So with quadratics, you had a vertex. With square root functions, you also have a vertex. So let's make a note of that. Your vertex is still hk. So over here in Desmos, let's look at the original function. hk was 0 and 0 because all you had was y equals the square root of x. So it's like the square root of x plus 0 or minus 0 underneath that radical. So the parent function starts with a vertex at 0, 0. Then we can see if I click and drag here, I can see, I don't want to look at that point where they intersect. I want to look at the vertex of this black graph where it says the vertex is 2, 1. So we can see this vertex is at the point 2, 1. So you can even compare where they've shifted left and right, up and down. So from looking at 0, 0 to 2, 1, this means that I've gone right 2 and up 1. My x values went from 0 to 2. My y values went from 0 to 1. So that's another way that you can look at it. If looking at the equation confuses you, or if you ever get mixed up, you can always default back to looking at the vertex and seeing how that's changed. Okay, let's do another example. I'm actually going to make this a little bit smaller so I have some room on my screen. You should still have some room on your paper, hopefully. All right, example 2. Let's do y equals 1/2 the square root of x plus 1 minus 3. All right, so let's graph this. 1 divided by 2, and then move your cursor over to create your square root. X plus 1. Move your cursor over so you're not underneath the square root anymore, and then minus 3 on the end. So these are kind of all the opposites of what we just looked at as far as the direction and the type of stretching that we were doing. So now we have if you kind of zoom out a little bit, you can see how this second function that we graphed is a little bit flatter. It doesn't come up quite as much. So you can see here, we start at 0, 0, and moving upward, you can see that it comes up a little bit higher than where this one comes up to. Right, so first we can tell that there's been a horizontal stretch. It doesn't look as high, it actually looks like it's been stretched out by the sides. So we'll start with describing that there's been a horizontal stretch. By a factor of 1/2. Okay, then let's look at how has our vertex moved from 0, 0, the parent function vertex at 0, 0, to this function has a vertex at -1, -3. So based on the x plus 1 over here, we do the opposite of what we think, which means instead of going right 1, we actually moved left 1. And the k value is exactly what it looks like. Instead of, or you'd move down 3 for that one. All right, and then finally, just looking at the vertex. You can also do that just by looking at the equation. It's the opposite sign of the h, but the same sign as the k. So when we write that vertex, that would be -1, -3.